Hello, let us discuss the solutions of a quadratic equation by completing square method. So this is an entirely different method than factorization. We have seen the factorization method. So where the middle term, suppose 4x minus 5 is equal to 0. This is the quadratic equation. Then by factorization method, we were finding the roots by like factorizing the middle term. Okay, two terms we were making there, but this method is entirely different than this factorization method. Then what is this method? Let us see. Let us take an example of the product of Sunita's age in years. 2 years ago and her age 4 years from now is one more than twice her present age. Then what is her present age? So here the product of Sunita's age 2 years ago. Let us take, let Sunita's present age is equal to x years. Then product of Sunita's age in 2 years ago. 2 years ago means x minus 2. And her age 4 years from now. Product here. 4 years from now means 4 years plus from the present age. For the present age we have to add 4 years. Is one more than twice her present age. Present age we have taken x. Twice. One more. Okay. One more than twice her present age. Then what is her present age? So here you can calculate it very easily. X into x, x square plus 4x minus 2x minus 8 is equal to 2x plus 1. Now x square plus 4x, if I take 2x this side it becomes minus 2x. Minus 2x plus 4x. So I will write it like this. I will just cancel. And minus 8 plus 1 come this side, become minus 1 minus 9. Okay, x square minus 9 is equal to 0. X square is equal to 9 and x is equal to plus or minus root 3 and x is equal to x is equal to plus or minus root 9, x is equal to plus or minus 3, and x, that is present age cannot be negative, so x is equal to 3 years. So present age of Sunita is 3 years. So this is how we calculate. Here you can observe the x is coming under square, directly under the square, completely under the square. So this you can make out, and we can take one more example. Let us take x plus 2 square minus 9 is equal to 0. Again here it's also very simple. X plus 2 square is equal to 9 if I take 9 this side, and x plus 2 is equal to plus minus 9, and x plus 2 is equal to plus, that is 3 1 term. If I remove it from the root it becomes plus or minus 3. X plus 2 is equal to minus 3, another. X is equal to, if I take it this side, 3 minus 2, that is 1. X is equal to, if I take it this side, minus 2 minus 3 minus 2 minus 5. So these are the two roots we get. So this is when we take x under the square. Okay, so already x is under the square, and in this case some examples you will see where x is not under the square. Suppose x square plus 4x minus 5 is equal to 0. Okay, so in this case if you are very well aware of completing square method and factorization method, you will say that this is also of the form x plus 2 whole square minus 9 is equal to 0 only, because x square a square plus b square plus 2 into a into b is 4x. I will say minus 9 is equal to 0. So again it is x square plus 4x, 4 minus 9 is minus 5, isn't it? So we get this only. That means we can directly add the roots whatever we get before. Okay, but x square plus 4x minus 5 is equal to 0. So if you have a very good knowledge, you can say that this is also of the form x plus 2 whole square minus 9 is equal to 0. Okay, the same roots you will get. How it is x plus 2 whole square? It is, if I just derive this, if I just solve this, you will get x square plus 2 square plus 2ab, that is 4x minus 9 is equal to 0. Here it is x square plus 4x plus 4 minus 9 minus 5, isn't it? It is of the form. But if you don't know and you want to solve it by completing square method, then first we have to solve this part. Okay, by completing square method. In your book it is nicely given. Go through that. Diagrammatically it is explained like this. Here it's a square, x into x, x square plus 4x is given this way, 4 and x, height is taken as this, and x into 4, 4x, it is equal to square plus 4x, that is it is a square, it is 4x, that is equal to x square plus 4x. Now if I just separate it into two parts, because I want to solve this by completing square method. This was a square, this is a rectangle. If I combine this, it won't be the square now, it is rectangle again. So I have to make it square again. How it can be done? I'll just make it half, that is 4, I'll make it half, 2 plus 2, and rest remains the same, x square plus 2 into x, 2x plus 2 into x, 2x. Okay, and next I'll take one of the two this side, and it becomes so 2 this side and 1 below. Okay, now you need this part, that is a square here, to complete the square. to make it a square, to make it this one again the square, you need this part. So that means it is of 2. 2 here, 2 here. If I join 2 and 2, it will become 2 square. So here x plus 2x plus 2x and 2 square. If I join this, I have to remove that square here. Minus 2 square. X square plus 2x, that is x square plus x into 2, 2x plus 2x plus square I have taken. So that is 2 square minus 2 square. Okay. Now it will be complete square. Okay. Minus 2 square. It is, I will write x plus 2. Even you can write it like this. It can be written x plus 2, x plus 2 into x plus x plus 2 into x plus x plus 2 into x plus 2x, 2 into x, 2x plus 2 square, this one minus 2 square, plus 2 square minus 2 square. So here you can write it like this, x plus 2 square minus 2 square, x plus 2 square, x plus 2 whole square minus 2 square. Okay, so now this part we have solved. Now this is remaining. Okay, this part I will write like this. X square plus 4x can be written in this way. X square plus 4x can be written x plus 2 square minus 2 square minus 5 is equal to 0. Minus 5 and x square plus 4x is this part by completing square. Now x plus 2 square, 4 minus 5 minus 9 is equal to 0. X plus 2, if I take this side, 9. X plus 2, if I remove the square, okay, and x plus 2 is equal to plus or minus 3. Root 9 means root 3. Root 9 means 3. Now x plus 2 is equal to plus 3. X plus 2 is equal to minus 3. X is equal to, if I take 2 that side, 3 minus 2 equal to 1. X is equal to minus 2, minus 3, minus 2, minus 5. So these are the roots by the method of completing square. Thank you.